Okay, let's dive right into this explainer and learn how to become a literal data detective. Today, we're mastering SQL subqueries, along with comparison and logical operators. Look, if you've ever stared at database code and felt like it was just this massive, confusing wall of text, seriously, don't sweat it. We're going to break this down so simply that honestly, a 16-year-old could totally crush it. You're about to learn how to make your database do all the heavy lifting for you.
Let's kick things off with a highly relatable scenario. Think about this. How do you actually search for data when you don't even know what you're looking for yet? Imagine you're trying to find all the players who beat the high score on a video game leaderboard. The catch? You don't actually know what the high score is. So if you don't know the exact number, how on earth do you ask the database to find the players who beat it? Well, that is the exact mystery we're going to solve today.
So part 1, what exactly is a subquery?
To solve cases where we're basically missing a crucial piece of the puzzle, we use this amazing tool called a subquery. Basically, it's just a query within a query. The inner query's job is to hunt down a hidden clue, like our mystery high score. Then the outer query grabs that clue to solve the whole problem. Think of it like a Russian nesting doll, or, for movie fans, a dream within a dream. It allows your database to adapt on the fly, so you don't have to hard-code specific numbers.
The absolute golden rule here is what I like to call the inside-out rule. The sequence goes exactly like this. First, you run the inner query. Second, extract that secret value. And third, run the outer query using that value. It's just like back in math class when you had to solve the equations inside the parentheses first, right? SQL does the exact same thing. It solves the inner query first to get the clue, and then passes it outward to the main query to finish the job.
All right, let's move on to using comparison operators.
Now, what's really cool is how we combine these concepts to make our code incredibly efficient. We're going to use comparison operators. The classic greater than, less than, or equal to. On the left side here, we've got the old, clunky, manual two-step process. First, you'd run a query to find the max score. Let's just say it's 9,000. Then, you'd have to write a brand new query searching for players with a score greater than 9,000. Kind of tedious, right? But check out the sleek approach on the right. Instead of that manual back and forth, a subquery does it all in one single step. You literally just ask for players where the score is greater than the result of your inner query. Boom, done.
Let's actually visualize this. Look at this leaderboard showing player names and their scores. Following our inside-out rule, the inner query first scans this table to find the absolute maximum score. It zips through the rows, spots 9,500, and secretly holds onto it. Then, the outer query instantly kicks in and filters out anyone whose score isn't greater than or equal to that hidden number. The database is literally doing the searching and the comparing at the exact same time.
Let's put this into practice together and see how you do.
All right, throw your detective hat on for a second. Can you find all the students with a score lower than the school average? Try to picture that inside-out rule in your head right now. Ask yourself, what is the secret clue you absolutely need to find first before you can even start filtering the students? I'll give you a second. Okay, you need the school average. That average is exactly what your inner query has to go find.
And this brilliantly illustrates the answer. We say select everything from students where score is less than, and then boom, we drop in our subquery inside the parentheses, select the average score from students. So the inner query calculates that average score first. Let's say the average is 75, it holds on to that number. Then the outer query uses the less than comparison operator to reveal our final list of students who scored below 75. See? It's really that simple.
Moving right along to something I love, the magical IN operator.
So here's the thing. Comparison operators like greater than or less than are fantastic, but they definitely have limits. They're meant for single numbers like an average or a high score. But what if your inner query uncovers a whole list of clues? Well, this is where the magical IN operator comes into play. The IN operator is a logical operator that checks if a value matches any item in a dynamic list generated by your inner query. Basically, it acts as a dynamic filter for multiple results rather than just one single number.
Let's look at this student club database showing student names and their associated club IDs. Let's say we want to find all the students enrolled in a science or math clubs, but we only know the club names, not their specific ID numbers. No problem. The inner query searches the clubs and generates a list of those relevant club IDs. Let's say it finds IDs 2 and 4. Then the outer query uses that in operator to check our main database. It literally goes row by row asking, hey, is this student's club ID in the list of 2 and 4? If yes, we have a match.
Next up, checking with the exists operator.
Finally, let's explore another logical operator that acts just a little bit differently. The exists operator acts kind of like a radar ping. It simply checks if the inner query returns any data at all, which results in a simple true or false. Unlike the in operator, exists really doesn't care about the specific values in a list. It doesn't care if the list contains club IDs 2, 4, or 1,000,000. It just wants to know, did the inner query find anything at all? Yes or no? If you're ever kind of confused about when to use which, here's a super simple breakdown. On the left, we see the in operator is your go-to for checking if a value matches a specific list. On the right, the exists operator is best when you just need to know if a record simply exists. To keep it super easy, use in when you're checking a shopping list of items against your cart, and use exists when you just want to see if the grocery store is even open.
Okay, let's quickly summarize everything we covered today. Subqueries, they're just queries inside queries. Remember to always solve inside out. Use your comparison operators for single values and use in or exists for lists and conditions. So your absolute biggest takeaways from this explainer are to remember that inside out rule and to leverage your comparison and logical operators to make your database do all the heavy lifting for you.
You now have the ultimate detective tools for dynamic data. You can actually find answers without even knowing exactly what you're looking for when you start. But as we wrap up, it does leave us with one totally mind-bending puzzle. You've mastered queries inside queries, but what happens when a query actually calls itself? Think about that for a bit, and we will definitely catch you next time.